So let's continue with our services discussion. I have shown you how node port and cluster IP services are used. Node port is used to access the application outside of the cluster, meaning from external world, for example, internet. And cluster IP is something which is accessible only within the cluster. So if you create cluster IP, there won't be any mapping of the service IP and port with the node IP and port, but that is not the case for node port. Now let's extend this discussion. What happens in services? What does it do? And how does it work? So you'll be surprised to know that you cannot call service as an object per se in Kubernetes. Why is that? Because it does something else. So the implementation of services is completely done by kube-proxy. And this is one of the major, in fact, the major work that Kubernetes does, kube-proxy does. Let's say we have these nodes 10, 168, 12, 13, and 14, and then we create a service. Now the service can be a node port or an IP address. Now, one thing I did not mention in the last video is that service by itself does load balancing also. Let's say you have a deployment with 10 replica sets, it will launch 10 pods, and the service will load balance the traffic to the pods using some algorithm. Let's not go into the algorithm of load balancing, service load balancing, which is something will not bother that much so and so. But yes, service does load balancing also. So you might feel that we have so many pods behind the service and the deployment. Where does service send the traffic to? Now this is one of the things, one of the important functionalities of service. Not only gives you IP address to connect to the application behind the deployment, it also load balances the traffic across all the pods in the deployment. Now, what does it exactly do? So here in bracket, I have mentioned IP address. So when we create a service, we mention port mappings, and in port mappings, we mention node port, port, and target port for node port service type, and only port and target port for cluster IP service type. So I'll not take example of them separately because eventually they do the same thing. I'll try to make you understand using node port, and hopefully you'll be able to extrapolate that to cluster IP, because node port does a little bit more, and whatever cluster IP does, that is completely done by node port also. So as I said, we mentioned the node IP address, we mentioned the node port in the service port mappings. Then we mentioned the port of the service. Then we mentioned the port where the application have been deployed on the pods. Now the implementation of this service is handled by kube-proxy. Now it does a very interesting thing because it is unlike any other objects in Kubernetes that we have discussed so far. So it creates this mapping of service IP and pods, meaning that whatever port mappings you are seeing here, node port and then service port and target port, along with the pods, which is there in the configuration itself, is actually moved to the IP tables of the node. Now, if you do not know what IP tables is, IP tables is used to forward traffic from one place to another within the node. So now here we are actually talking about the node. It is not happening using any pod. So what kube-proxy does is it gets the mapping of the node port and then the service port and then the pods, and that mapping is pushed down to IP tables of the node. It does not create any pod whatsoever. Now let's try to see if we can get some information about IP tables. I don't think we'll be able to get much because it depends on the operating system, and the operating system that I'm using, Red Hat Enterprise Linux 7, does not show much in the IP tables. But again, I'll try to give you an idea what it does. Also, you can see these things when you create a service. This mapping, which is pushed down to IP tables, is actually logged in the kube-proxy logs, which you have not seen so far. And again, as I said, I'm using Red Hat Enterprise Linux 7. For some reason, I was not able to find those logs in the kube-proxy logs. Neither I was able to find the operating system log. But that's okay, because I'll give you an idea how it works. And when a service is created, that's what happens. So the conclusion is that when you create a service, kube-proxy makes some entry to the IP tables of each node. So here we have three nodes and we have three kube-proxies. The moment we create a service, the mapping, the port mapping of node, service and the target pods are actually entered in the IP tables, unlike any other Kubernetes objects. Okay, so that's what a service is. It does not run as a pod. It does not run as a deployment. It does not run as a replica set or anything Kubernetes like as such. It is just an entry made in the IP tables of each individual node, which is done by kube-proxy. The next thing I want to talk about is the IP address of the services itself. I don't know whether you noticed or not, but the IP address was not part of the network range which was mentioned during Kubernetes cluster creation. We had mentioned the pod CIDR to be 10.20, but the IP address of the service was different. So it's okay, I'll create it again and show you that. So I'm getting all the resources here in prod namespace. Notice the IP address of the pod, of the pods rather, and it belongs to the network that we had mentioned while creating the cluster. But the IP address of the service, I have created this cluster IP service, and the IP address of the service is different. It does not belong to the network range that we had mentioned while creating the Kubernetes cluster, the pod CIDR range. So it means that the IP address is not being generated from the network range that we had mentioned. Now what I'll do is I'll create the node port service also, and we'll see what cluster IP do we get for node port service. And this is the file for node port. Let us go ahead and create it. Okay, now it is saying that there's some error parsing 7.8 HTTP web page, error converting YAML to JSON, and it's a little confusing. Where did we get JSON from? Now don't worry too much about it. There's some indentation problem because of which we got this error. So I'll change the indentation. So now if you see it has been created, I know it sounds weird and looks weird too, that I did not do anything. I just changed the indentation. I removed the spaces and did it again. YAML can confuse you a lot, so don't worry too much. If you get something like this, like error converting YAML to JSON, make sure to change the indentation or fix the indentation and run the command again. Alright, so one more service has been created, which is node port, and the cluster IP is 10.106.21.80. Now the IP address of the node can be found from, you can use the external services, public IP address in case of EC2 and external IP in case of GC instance. And we have this deployment and replica set created as part of the deployment. Basically what I'm doing here is that I have created two services for the same deployment. Yes, you can do that. One of the services is node port and the other one is cluster IP. And when you do that, when let's say you want to have an both internal and external access to the service, but you do not want to use the same cluster IP for some reason. Moreover, you can create multiple cluster IP services also for the same deployment. All right, that is not the purpose of this video. I just want to show you where this IP address of the services are coming from. Definitely, it is not coming from the network CIDR range that we have provided while creating the Kubernetes cluster. So let's see where it is coming from. So to get that information, you have to go to the process or the pod of API server. Now this is the process, API server process, kube API server. And now if you see here, there's this option, service cluster IP range. And the IP range is 10.96.00.12. So this is the one. And the IP address is actually coming from this option. Now if I go and check the pod also, let's see what we get. Let's check the API server pod. Now I have described the pod. Now it says that the command that was run to start this API server pod is this one. Here as well, you can find the service cluster IP range, which is 10.96.00.12. And these are the IP addresses of the services. Actually, this IP address belong to 1096.0.0.12. Now let me show you a few more stuff. I was talking about the IP tables. So when you create a service, kube-proxy pushes the mapping to the IP tables of all of the nodes that we have in our Kubernetes cluster. I'll show you only one node, and the remaining node would be the same. To check that, you type sudo iptables -l -t is the table type. I want to see the NAT table type, and let's just try to search the service name that we used. Don't worry about the command too much, the iptables command. Just I want to show you, do not need to know this, but of course it's good to give you the information. So this is what it is. It is saying that this cluster IP service has been created, and it is actually there in the IP table of the master node. And the same thing would be there in the worker nodes also, if you go and check. I'll not do that. Now let's see the other one, the node port. Now in node port, we have the port of the node extra. So we have this TCP DPT 32500, which we had mentioned as node port, and that thing is there as well. So you don't have to understand what does it signify, what does it mean, what is this cube mark mask and cube SVC, etc. What I'm trying to say here is that when you create a service, essentially the IP tables is modified, which is done by kube-proxy. It has been done by kube-proxy. Now, if I go ahead and delete the services, these entries would not be there. So let me go ahead and do that. So the service K8 service cluster IP has been deleted. Let's see if we can find that again in the IP tables. Now, if you see, that entry has been gone from the node IP tables, and the same thing would happen for node port also. But as I have not deleted node port, I should be able to find that entry of node port in the services, in the IP tables. Now here you see we have the information as is. So internally it is doing the mapping of the service IP and port to the backend pods, which is not mentioned here completely, but don't worry about it because internally it is being done, and that is handled by kube-proxy also. One more interesting thing that I want to that I want to show you here is see the IP address 10.106.21.80. It is actually the cluster IP address of the node port service that we just created, 10.106.21 and 80. So that's what it is. That's what service does. It creates an entry in the IP tables of all the nodes, and the entry is created by kube-proxy. Now, how does the traffic flow happen in that case? So when we do a curl of the service, let's say I do this and the backend port is 80, if I'm not wrong, or it's 8080, and we see this output, which is actually the application that we have deployed inside of the deployment using the pods. Now, how does this traffic flow happen? The traffic flow is not that complicated, it's pretty straightforward. We have this node, and of course we have IP table in this node. Now remember that I'm showing only one node here, and the same thing happens for all the nodes. Now as service does a load balancing, it will happen node by node basis depending on how many pods are there in this node. So for, let's say, this particular node has 3 pods, so the flow of traffic would be same for all the 3 pods. As you have already seen that the IP table actually contains the mapping of node IP port, service IP port, and the pod IP port. On a high level, you might have understood that the mapping is actually there in the IP table of all the nodes. Now, when we use either node IP or cluster IP followed by the port number that we have just done using the curl command, what happens is that it goes to the node. From the node, it actually goes to the IP table. And the moment it goes to the IP table, everything is pretty straightforward because we have the mapping. So it finds out, okay, for this particular node IP and port, this is the service IP and port. And from this service IP and port, I should send to all these pods. The same thing is there for cluster IP also. And in cluster IP, the node IP port is not there. The mapping of node IP is not there. We have only service IP and pod IP. So it goes to the service IP, and then it finds out the IP address of all the pods, and then the service also does a load balancing, which is done by kube-proxy, because service, as you have seen, is actually not there. It's an IP table entry. Each service is nothing but IP table entry. The load balancing is done by kube-proxy also. Now, finally, of course, it goes to the pod in the backend. There are a few more things that I want to show you. The logging of kube-proxy itself. I don't think I'll be able to get much information. I'm not sure for why, but whenever we create a service, the entry should be there in the kube-proxy logs. So let us try to see what we have in kube-proxy logs. I have my kube-proxy pods in the kube system namespace, and this is one of the kube-proxy logs. Let us do a override so that we can find out where is it. So this kube-proxy pod is in worker 2, this is in master, and this pod is in worker 1. Let's see the logs of the pods. Now I'm trying to get the log here, and while getting the logs also you have to mention the namespace, remember that. Sorry, the command is wrong. It should not be get log, it should be logs. Here, if you see, there are some entries, but these are not enough actually. The one thing that I can show you here is that it is using some mode which is called iptables mode. So this is the line using iptables proxy here. You do not have to understand this. Now, the services that we created should have had an entry in this log, but I'm unable to find it, and I tried googling also without much luck. But typically it seems like it's a red hat error if I'm not wrong. There are some patches which are not there. I should have applied some patches, but anyway, should be okay. So what happens is that when you create a service, there would be one entry in this kube-proxy pods, which is not there here. That's okay. If you want to see the services logs, you can see that in a production cluster if you want. In a nutshell, this is what service does. So it's not an object, it's not running as a pod, it is just an IP table entry which is done by kube-proxy. That's what a service is.